is a residential condominium, high-end residential condominium per se. And basically, there are two structures, two towers, two residential towers. And each tower, on one side, there are duplex, one side is the simplex. And these two towers, say, of more than 140-meter height, and say this is one side is the east tower duplex, west tower duplex on one side, and other side view is the simplex on the same towers, simplex towers. Number of units are shown here, and the height of towers is, on today's date, it is not that way skyscraper or very high tall or something like that. It's hardly 140-meter plus. And so anybody can say, then what's the uniqueness for this project? Now, as I was explaining, that Rahul being the dreamer, he is trying to rationalize, yes, for the high end, what they want for. Basically, in this area, the high-end people always having an aspiration to live in bungalows. So he has created duplex and simplex bungalows on the sky, in the atmosphere. That's the basic perception. As if whenever you are entering inside a tower, and whenever you are entering inside your particular premise, then you will have a feeling that you are inside your own self-contained bungalow. It may be duplex, it may be simplex. They are having their own lash of green. They have their garden. They have their big trees, landscaping. Everything is there. Even the water body, everything is inside each flat. And there's a uniqueness, and a feeling gives it to it. Still, then I should say that these two towers connected in a basement. So it's a big basement, large basement connecting both the towers, around 5,000 square meter of basement, accommodating mainly a car parks and some services, utilities like fire pump house, STPs, etc. And basically, and also accommodating certain lift lobbies for the from the basement itself, which carries the people to the top. And it has a deck at the level of 5-meter height. So far, this building is conceived. It is nothing great. Greatness has come when Rahul, along with the architect, I must say, has connected these two towers with a sky bridge at a level of 100-meter plus. A sky bridge you see here in this display. This sky bridge is not a bridge, is not only a bridge, it is a steel structural bridge. Towers are made of RCC, whereas this steel structural bridge is not for only moving. It is a 3-storied block comprising of all utilities and amenities which a high-end dweller can expect as their utility services. What not it is having there. This bridge is having its own swimming pool, having its jacuzzi, having a kids pool, having its gym, having its party deck, having its view deck, then spa, then salon, then your party area, then your conference room, home theater, whatnot. Whatever one can expect to have for his best living, higher standard of living. All amenities are put inside this 3-storied bridge. That has become made the building a landmark, and made this project a landmark project, and has been captured by NATSG also and has placed it as a unique building structure, and in the list of the unique building structure of the world. So there lies the beauty, there lies the uniqueness. Now, the steel structured bridge, as I have explained, it has got a lot of design complications, fabrication intricacy, erection intricacy, all need certain specialized tools, specialized knowledge, specialized how to look at. And there lies our expertise. And we are very happy today that this kind of, and in this top, and I say this at the topmost roof level, there is having a lush garden, having tall trees in the extent of 20 feet or plus height. Now, recently, we faced a big cyclone of Amphan, and where wind crosses more than 135 kilometers per speed. Now, what is the gust wind? I do not know. Maybe more than that. Surely it will be more than that. But nothing has fallen down. Nothing has been damaged in this building constructed, and we believe that it has passed. It has passed its landmarks. So now today, I am very happy and I'm grateful that this MXBM has organized this webinar, taking this project as in the front, and especially the steel structure, the concentration of the steel structure design, which is really unique. And today we have our friends and our partners, Wave Structure. So Callum is here, Mr. Wang, who is there. They are totally, it is their design, their thought, under the leadership of Dr. Hussain, I believe. He may also likely to join, I believe, for some time. So Wave Structure is the organization in Singapore who was deeply associated, and they are supported by our Indian design team of MN Consultant, Utpal, Shastra, and Ankit and team. So this Indian consultant had given all supports to Wave Structure for the local conditions, local requirements, local statutes, as well as they have continued to give to remain work hand in hand during the entire construction phase. Both our MN consultant and Wave Structure is available here today with us. And another person you might have seen in the screen, Krishnendu Ghosh. He is our frontline captain who has led the entire scene. So we're very happy that to have this webinar today, and I hope that Callum and Mr. Satra's team will explain the design nitty-gritty, all the question answers, whatever relevant to this that will come up. We'll try to reply, and hope and that this kind of steel structure, use of steel structure in the building shall propagate the use of steel in buildings in India also. Today, we are a little bit behind for using steel structure in buildings because of the cost consideration. But in other issues, there are a lot of advantages. This bridge or this kind of things could not be made without the steel. So now I hand over to Callum. So, or the Ruchir. I didn't find Ruchir so far. So take it on, please. Thank you.
Thank you very much, PK. You know how pleased we are to be part of this exciting project. And I'm very glad that you share the feelings that we have made friends in the construction of this. Today, to everybody who's listening, I intend to take you through, with the help of MNC and others and the project management team from the client, these items. It will be quite straightforward, and let us begin with where we started. We started on the site. The site was empty when we started. This was December 2010. This project has been 10 years in the making, but we do have a little bit of video here, which actually reveals PK and our client and the absolute absence of any high rise anywhere nearby. This was the start of the vision, the start of the vision. The building, did have a vision. We have this one sketch that was made in the earliest of days by the architect to connect his cloud between two towers. That's the way he saw it. The architect liked it, and we built up the whole thing into this. The architect's impression like this. Of course, the structural engineer has to become involved, and he has to do his visualization as well. And the engineering. The engineering gave us a piled raft, a single-story basement, a 5-meter high podium, which we will describe later, also known as our E-deck. Reinforced concrete frame, typically 5.1 meter story heights, very high. A big steel grillage, which we will enjoy looking at later. And of course, the steel Deya, which sits suspended on 4 bearings between the 2 towers. Now, to think of the anatomy of the Deya. The Deya is supported by the towers. The towers use bearings to support the Deya. The Deya itself will do what it wants, but we want it to do things. We want the towers will vibrate under load. They will move around. These ones will not move around in the same manner. They are asynchronous. We have analyzed them. They are asynchronous. They're not going to move together. So while taking the substantial load of the Deya, we have to accommodate their movements. The Deya itself will will take the lateral load from the wind, will support the swimming pool, will provide all the facilities that are required, and the bearings must interface the two to enable damping and isolation and to ensure human comfort, and also through this provide safety and for the towers to ensure that the three work together harmoniously and to the mutual advantage of them all. To do this, we actually undertook analysis. This is analysis that we undertook, which simulates earthquake loading. Light loading, you can see the towers move gently together, largely, not much in the way of differential movement. But of course, we have to allow for the earthquakes that do hit Kolkata, not unusually, sometimes very severely. When this load is applied, then the buildings will start to move in a different manner. They still seem to be moving a little bit together, but because of the detail of the structural arrangement, you can now see that they are starting to twist against each other. Thus, our Deya has to accommodate this differential movement between the two. And the bearings that support that Deya have to be very carefully considered. We went through many, many options. Here are just a couple of them. We could pin at each end. Yes, but if we do that, then all the load from one side goes directly into the other side. This is not desirable load on the Deya or applied to the other tower. We could release one end using a roller or a ball connection. This is true, but then one tower would have to support all the inertia of the Deya. That's not the best arrangement. What we've settled upon is base isolation at both ends. All the Deya sits actually on 4 bearings, 2 on each side. These bearings are sprung loaded in all directions. So thus they mitigate the seismic demand by reducing the motion from the Deya into the buildings. It is taken up through the sprung loaded bearings. This improves the human comfort aspect because the Deya itself acts as a damper on the buildings. In the same way as a tuned mass damper or a hydraulic damper would do, our Deya provides damping for the towers. And in addition, the spring nature of the bearings means that they are restored to their original position after any event that causes them to move. Okay, so our base isolation system achieves resistance to the heavy load. Significant, I think you'd agree, 36,000 kilonewtons. Resistance to surface loads, both horizontally and vertically. We reduce the displacement and ensure better human comfort than we would otherwise have when the shock of an earthquake hits. We introduce damping through the use of these flexible bearings. And so the safety of the structure is enhanced. And we maintain the flexibility in maintaining this performance and realignment after the event. There will be no more than 20 millimeters or so of permanent movement on the bearings, and that's only due to friction. So we need a Deya, we need a frame. This is where we ended up. This is the conceptual process we went through to get there. A longitudinal truss, pair of them, end to end, take a lot of the load. Transverse trusses, yes, of course, to give the area and the profile, which is so characteristic of this. A transverse trusses that fit into the longitudinal trusses. We thought originally that a horizontal arch might be necessary to take the horizontal load in the narrow section in the center of the Deya. In the end, we didn't use it. It was not required. The other components were sufficient. Because of the shallow cross section in the middle, in the structure, a vertical arch, which you can see in here, was added to strengthen the longitudinal truss. In the middle, there's an oculus. A separate truss was required for that because it disrupted all the other trusses. A roof arch to start providing space. Externally, a diagrid to provide rigidity into the Deya, resist twisting effect, and provide a surface on which we could start building the cladding. And at the end, to suit the architecture, there was a crown required. That was the design. But in addition, we had to consider other aspects. Once we had a structure that worked, we had to add in the final condition additional members which were required to suit the erection process. So these characteristics, these loading was provided by Eversendai through our checking systems, and we doubled up wherever we could. Then we had additional elements for additional floors, which did not form part of the structural framing, which we had to add in. And in addition, our client very sensibly had bought a load of steel, and there were certain cross sections, certain sections that were determined by the availability of material. This was, we considered to be a good green move rather than producing loads more steel unnecessarily. So all of these things provided a refinement, shall I say, to the anatomy of the structure. Then we, having decided on this design, is how to assemble it, how to put it together. It's high up, it's complicated. We have an area here that we could work away from. We have a very robust structure on either side. Flat slab structure, very, very few beams, but very eccentrically loaded. Coming up to our Deya, how do you put that up there? Well, the first thing you need is a very solid landing strip for it. This is a view onto one of the grillages that support the bearings. These beams are 2.5 meters deep each. And because, as you will see, the towers do not line up, they are eccentric because the skew that exists on the loading. These are taken down into the concrete walls of the main tower below. To fabricate the Deya, this was going to be done in Tirupalli or Trichy to us, some of us. It was decided that we would fabricate the nodes to start with and ship them up individually and assemble once we got to site. When the details started to arrive, we discovered that some of the nodes were extraordinarily complex. I think you wouldn't really like to put this on a drawing board and try and draw it out. But with the expertise of our colleagues at L&T and Eversendai, joints such as this, and this is not the only complicated one, were designed using computers, cut using computers, and welded using computer-controlled techniques. This was quite impressive. The bearings themselves, we said that they have to accommodate large amounts of movement. They have to take a great deal of load, both horizontally and vertically. And we had these fabricated, designed, detailed, and fabricated to our specification in New York State in the US. Each bearing weighs 14.5 tons, is about 2.5 meters square, and there are 4 of them. It was a big day when we finally got those started on site. So the bearings in place, the component parts of the Deya are with us, and we then started erecting both up on the tower, as you can see. If you look on the recessed sections, we have assembled part of the Deya, but we've also assembled a fairly substantial amount of temporary works to hold the Deya down as it's going to lift up a section in the middle. And we will also fabricate on the ground. Looking down on the ground, this is the section that we will lift. Some 500 tons of steel will get lifted using strand jacks on each corner. On the ground, the steel starts to acquire a scale. It was bigger than it was on the drawings. It was complicated, but it all went together incredibly well, despite it. You can see here the arches that go over the center area. The gray paint is intumescent paint, providing fire protection. Work carried on day and night. Let me now pass over to MNC, who were our guys most closely associated with the work on site.
Hello, everybody.
This to
This is
you.
Upal Santra. Yeah, hello, everybody.
Yeah.
Welcome, everybody. It's a great pleasure to have you all and the entire web team there in Singapore, sitting there, Mr. Banerjee and Mr. Ghosh, and all the organizers. Thank you very much. Well, it's a big journey. You can understand that we started the entire inception in the year 2010 and almost completed last year. So still some nitty-gritties are there, but not with the there, but with some building finishing are still left out, but we are almost there. So 10 years of journey with this through. Well, it was a long journey, but was a very satisfying journey. And it was a very learning journey also. And many of the things, you know, while doing it, it was a first time for us in our life. And probably at this age, at this time of the, we could have implemented much more things, but you can understand that when we started the inception in the year of 2010, 2011, 2012, things were not that smart than what we have today. But in spite of that, we managed to do this complicated thing with the help of our able guidance by Dr. Hussain and the entire help that the forum team has given us. And we work together with web, supplying data, supplying the codal provisions, or supplying the codal requirement, and we worked together. It was a great team effort, and at the end of the day, it was came to so successful. Let me go through a very statistical data of the bridge. It's a, I would say, a key data, a statistical data, I would say. The bridge span is about 100 meters, bearing to bearing, and you have 5 meters overhang. So the entire stretch of the bridge is about 110 meters. And this entire bridge has been lifted and set at a level of 100 meters. And there are 4 floors inside. And the type of steel sections that has been used is about 1,500. There are about 1,090 welded joints. There are about 1,317 splice joints. And the number of bolts, it's amazing. It's 30,000, my goodness. And that's the thicknesses of plates. Well, we couldn't imagine that in the beginning, but it ranged from 10 millimeter to 150 millimeter. It's amazing. And the grade of steel was E350. Weight of the structure is 2,340 ton. Next slide, please. Next slide, please. Yeah. Right. Now, the basic concept of this base isolation, I think Callum has gone through the design aspect. We had to see, we had troubles. We had, my goodness, working nights and working day and night. We spent days and nights how to support this, because the amount of load this monster is having and the amount of load that is going to come up into the building, the buildings were not standing. It was a very difficult task for all of us to design the building itself with that amount of lateral load that is going to come during the earthquake, as well as when earthquake was the most severe of the whole thing because of its mass. Now, we tried several options, as Kalam said, pin, pin roller, but none of them, as he explained, that was giving us the right result. So what we thought, that let's not free off the load. Let's keep the load, but tone down the load so that the building will be capable of taking that amount of load and behave to our satisfaction and to the human comfort also. So what will be the material? Now that material, what we thought is that base isolation. It's called the erratic-wake isolation bearing. It was designed at New York by R.J. Watson, and it was manufactured by Mageba and supplied to us. As Kalam also said, that each bearing weighed about 14.5 metric ton, and it was a job again to lift them up at that level, which was again a job. And mind you that these type of things we have never done. Nobody has done in their life. So all the time we had to do some firefighting, and we came out successful, and it's a pride that we have done it. Now you see what the bearing has done really. Now the earthquake load in the total earthquake base shear is 1,440 ton, which by virtue of this bearing, it has toned down to 180 metric ton in each bearing. So you can see that each of the bearing with the load that was supposed to come as 360 metric ton has toned down to 180 ton, which was manageable. So the bearing is really what it is doing. It has toned down the load, and the load is approximately half of it. Now the bearing also had the capacity to move in each direction, one in either directions, and one direction along the longitudinally, transversely it is about 250 millimeter, and in transverse direction it can go about 200 millimeter. And the recent cyclone that Mr. Banerjee told us about, this in the Amphan, which reached about 140, 150 kilometers per hour as gust wind speed. Well, the bridge moved. Yes, the bridge moved, and well, it has come to its original location. We have studied, we have examined all the thing, and to our satisfaction, the bearings have passed through its testing and real life testing. And we are so happy to announce that it has behaved to our satisfaction and the mathematics. Well, next slide, please. Now, while this is the bearing, you can see. Now, while doing this, keeping this bearing, again, as I repeatedly saying that it was all first time to us, the four things that we thought of is the safety of this bearing. It is the serviceability, that in anything goes wrong, we can service these bearings and nothing. So the performance is kept, although it is the lifespan is it's a lifelong, but still we should always keep the serviceability in accessibility and the serviceability to the bearing. Now the last thing, and the most important thing, and which came to our mind at the last moment, is that somewhere or something which we always face in bridges normally, that the bearings need to be replaced at some point of time during its lifetime. Now, although with all our trials, we also found out that some point of time, these bearings may have to be replaced. Now, how to do it with this monster on top of it? How to do it? Now, what we did, you can see this thing, a pedestal which was constructed, and that pedestal can, support a strand jack, and we can lift the entire bridge together and replace the bearing. The bearing has the capacity of doing it, and we have kept everything possible things there so that the bearings can be replaced. Next slide, please. Now, while this, the next slide, please. Callum, next slide, please. Sorry, can somebody go for the next slide? Fabrication and erection. Hello. Is
Kalam out of power. Kalam, can you hear?
yeah, Callum, can you go to the next slide? You can see in the picture the bearing itself, how complicated it was, and there's a thick steel plate at the bottom, and you have a steel plate at the top, and the entire bearing is within that thing. It was a lead rubber bearing and reinforced with steel plates, and the central core, lead core, was taking all the shocks, and the vertical load is taken by the steel plates and the rubber. Is still not there?
Just a moment. Can I?
Yeah. Ankit, you go on with that.
Yeah, I'll just share the screen. Yeah.
Yeah. Please do it. And this bearing is already in place, and the part of the monster is sitting onto it. You can see this thing, and the corner there, is the provision for that pedestal. Yeah. Good.
Ankit is taking over the screen.
Yeah. Now it has come. Fine. Thank you. Now the fabrication erection, as Callum was telling you in the beginning, it was one of the most complex. You can't find the screen, Ankit?
Yeah, it's
Mr. Banerjee, can you see the screen?
The screen is on. You can continue.
Yes, it's
Okay.
on. Yeah.
Okay, fine. So so what Callum said, that it was again a job for us to how to fabricate and erect the entire monster and do it there. Now you can see we have done there we divided the entire bridge into 3 segments: the end segment, 2 on the either side, and the middle segment. Now the end segment was sitting on the building on the bearings, and that was fabricated on the building itself. You can see it there. The part of the king truss is being sitting on the building and is being fabricated, and there is you can see the post there that is coming up, which will hold the strand jack on top of it to lift the mid segment together from the ground. Now, next slide, please. Okay, next slide.
Yeah, it's done.
Yeah. Now this on the part of the king truss is there, and the transverse truss is being attached there, and you can see one of the joint there at the top corner, how complex it is, and my goodness, it was not possible for us to make a drawing of it. It has to be a 3D drawing, and we used a very sophisticated software to do it, and then well, you can imagine what complicated it was. So the transverse truss was provided to connect the 2 king truss, so that the shape of the entire thing and the stability of the king truss was also being established. And this end part is acting as a bracket on which the mid segment will be placed there at the, you'll see that thing, how the mid segment will be placed there. And the entire, because while lifting it up, the strand jack and etc. is placed on this end bearing and the end segment, and the end segment was designed with the cantilever design with the entire load of the middle segment. Next slide, please. So the end segment with the connecting floor beams and infills are almost there. It is now looks very sturdy, and it is now capable of handling the load of the mid segment, which will be lifted from the ground. The mid segment was, as you will see right now, it was fabricated at the ground. The basic structure was fabricated at the ground, and it was lifted. You can see the complicated structure at the top corner of the photograph of it. Next slide, please. Next slide. Yeah, now you see the mid segment, the middle part is assembled on the ground, and it is being lifted with strand jack on top of this building at the 100 meters level, and the middle part has been joined there. And now after joining, the entire truss, the king truss and the top arch is taking the entire load. Now it is stable, but while it is being lifted, the end segment has to take the entire load as a cantilever. So we did a temporary design for that thing, so that it is capable of taking the load. So it was also it was a later on addition to the design that we have done earlier. And now while lifting this thing, it was done in the time of summer, and Calcutta, as you can understand, that these cyclones and these nor'westers are quite frequent, and we frequently see those things which can disturb the entire erection process, and the swinging of the entire bridge can happen. So what we did is we provided some wind arresters in the buildings. You can see that these are marked. So suppose while erecting, and it happened also, I remember, while doing so, if the entire bridge swings, if there's a cyclone or there's some storm that is happening, it can swing. So temporarily we can lock those in these arresters, and for temporarily we won't lift that up. So when the storm is over, then we can again lift it up. So we provided that at different levels. And mind you, on that day, the lifting day, there was some storm happened, and we had to, in fact, arrest that. It's much at the top level. We had to arrest that for some time. And then again, checking all of them, the lifting started. We planned initially to lift the entire thing in 2 days' time, 2 to 3 days' time. But finally, because of these storms and some level differences, it took about 5 to 6 days' time to lift the entire thing, and it's the entire thing placed in position after 6 days. Now, the middle segment, you can understand you can see the photograph that it was it's really a complicated structure. It's with all sorts of complicated members there, connectors there, and these were all supported on temporary trestles. And again, it was a challenge. This was it was erected at a ground floor slab, the roof of a basement. So the roof of a basement has to be again designed to take this entire load. Now you can see the complexity of the middle segment. Now it is complete, and it is now ready to go up there. Now it's from the pillars, it is the post, it has been released, and it is about to be started to be lifted. Now, Ankit, there it goes. Ankit, next slide, please. Yeah, there it goes. The temporary trestles on the ground has come up from that. No support is there. It is hanging from the strand jacks from the end segments that it is hung there, and it is getting lifted slowly. The speed was very slow, of course, and then the end segment is now ready to receive the entire middle segment. There, next slide, please. And there it goes, and the middle segment has been attached to the end segment, and the entire thing is in place there, and you can see the top view. Now the concreting and the other things will be in place. Enjoy the video that you can have. It's the erection, entire erection process is there. Mind you, this is it's a much faster pace that has been recorded. This was very slow, but you can well imagine that what the complexity and what the pain that we took in doing so. Don't get afraid with the leaning of the towers. It is a distortion in the picture, so don't get worried about it. It seems it's getting stuck there, but don't get worried. It was a distortion in the picture. Well, there it comes. There it goes. And mind you, we were continuously monitoring while the erection process was going on, that whether there is a difference. We had a talk with the contractor that we allowed some amount of, very minimal amount of rotation slope in the while the erection is going on. So we kept on keeping the control over it, so that it is not tilted on one side, so that one of the jack will take much more load. So there it is. At this point of time, we think, I remember there was a storm came, and we stopped there for some 2-3 days and checked all things there, and then again re-erected, and the entire process was completed on the 6th day probably. Yes, now it is there. Thank you very much. It's good. Thank you very much. The journey was done. But it is now secured in place. The concrete is being done, and a series of checks have been done at site. Non-destructive tests and bolt talking, site welding, all done. Magnetic particle test. Now, in fact, this is the first episode where we have now concentrated mostly on the design part of the erection part of this. Now, the quality control, the checking, everything is going to be in detail in another episode, because itself is so complicated and this thing. So we have done quite a number of checking, and while the erection, when the fabrication was being done, and all of them we signed off till we are satisfied. Thank you very much. Now I hand it over to Callum, if he's there.
Yeah, in that case, Huanggu will now take over.
Yeah,
Callum has some connection problems, so Huanggu is taking over.
Yeah. Hi, Hanga. Welcome.
Thanks. Let's go through the part 5. Okay, next slide. So the Deya is on top of the tower already. So it's the construction of the decking floor. The decking floor is important for the structures because it's acting as a rigid diaphragm and to give the stiffness to the Deya. Next. You can from side to see this the working in progress for the external die-grid structures, and this is for the facade. Eventually, it will be applied in. Please next. And this is another views of the external facade die-grids. Okay, after the finish, they will go into the top, which this is on top of the level 34, if I'm not wrong. So this is for all the facilities, including the swimming pool and view deckings. Next slide. Looking from top, we can see the after nearly to finish of the Deya with a steel structure below, but with all the facilities and all the staffs on top. Next. Okay, please enjoy these videos, which is we took from the drone. So we're looking from the far and to the near to close this huge structure, just spanning from the one tower to another. The facade cladding is in progress. All right, so this is finished part 5. Let's go to the part 6 next. There's and next, yeah. Just few days, couple of days back, there's a cyclone in 20 May. I think everyone knows, yeah, this is events and a very severe wind event with a huge, so-called large the wind speed, almost close to the design wind speed. And next, oh yeah, so this is shows the after this event, wind events, actually there's a very minor or even no damage to the structure, of course, even though the damage to the finishes and to the cladding. After the inspection, we find some minor cracks to the ceilings. Yeah. So this is give the very good I would say testing to the structure in terms of the performance of the Deya. All right, next. Yeah, come to the Anki, please.
Yeah. Now we will talk about. Hello, good afternoon, everybody. Very good explanation by Callum, Huangu, and Utpal sir, how the main structure of Deya was built and placed at site. But along with the main structures, there were a lot of associated structures which played a very huge role in making what Deya is. And there are hundreds. So we are just talking about 2 structures right now and a detail why they are in importance of this. But in the atmosphere, all the detailed small structures were done with precision engineering and precision construction. So you can see a sky garden all with so many trees at the top at 100-meter level. When the trees are at 100 meter and when there is a wind speed of 150 kilometer in the gust, there's always a chance of this getting down. And if somehow this falls from top, then it can be a catastrophic failure. But with a precision engineering and design, we were able to make these trees foundation such that they could withstand this pressure. So there were very different types of trees, what landscape wanted, and we wanted to give them a free hand so that their creativity is not lost. And there were palm trees and other kind of trees. And based on the height of the trees, there were 2 kind of support, one the root support and one the trunk support. Most of the trees were taller, so they have both the support. Some smaller trees had the root support only. This is basic sketch showing that the trunk support, which was done at the top with a steel collar, and all the things were done with galvanized plates and SS wire so that does not get rusted in the wind and the rains. There is a drainage arrangement at the bottom and a planter wall, but we did not took any support on the planter wall. Everything was supported in the steel deck below with a pedestal on the top. So These are the types of the trees and the canopy spread for them. At the top were the system for root balls for the smaller trees, and at the bottom are the SS wires and the leads which were used for higher tree supports. These were some of the detailing which we did, and a lot of things were changed on site also. So the SS wire was anchored in the pedestal, into the pedestal, which was getting supported from the deck sheet and the concrete that we have done. We use special chemical anchors from Hilti to get the support and the string that we needed. And above that were the plates installed on them, so that on that we can tie the SS wires. These are the pictures of the trees after the cyclone, taken just few days back, and everything is all right. Nothing has been, none of the trees has been damaged or distorted. There's one important structure with Deya. With the 2340 ton of Deya, there was a temporary structure of 400 tons of hanging scaffolding, without which we could not have built what Deya is right now. And it was itself a challenge making a hanging scaffolding. And as the name suggests, it was hanging from the main structure in the sky. So this was a, if you can see the blue below, there was a platforms below from the sky hanging below. And on the top, if you see the plan, the hanging scaffolding was needed everywhere to do the facade, to do the structural work, to do everything. I mean, whatever plumbing work, MEP work, everything. And it itself was a challenge. So these are a few sketches to show how the hanging platforms been done. And from the hanging platforms, at few places, we have to make one cantilever platform to access the regions for the facade working, because facade was itself a project here. These were some of the earlier sketches we did. How, see, a very important part of this project was, of this structure was that if there was huge intumescent paint layers of 6 or 7, we can't damage these paints while making this temporary structures. So we have to introduce a system of bolting such that it hangs the platform and the columns, but still does not damage it. And we were very successfully able to do it. These are some of the sequence in which it was done. We had placed a IMCC section at the top, and then both sides, and then the bolting was done, and from that the column was hanged below. These are few of the photographs of actual work done at site, and the engineering done just to hand the scaffold and the connections, and to keep the safety of thousands of construction workers who were working on this day in, day out. And glad to tell you that in all the circumstances, none of the single accident happened, and it was very, very successful to do this. Now I like to hand over from Mr. Krishnendu from Forum to take you a little bit through construction process and visual treat of what is inside there, which is also itself a treat. Krishnendu, handing over to you.
Yeah, thank you, Ankit.
So before Krishnendu, just a moment.
Yes, sir.
Yeah. I find more than 200 participants here. It's great pleasure for us. While I spoke that we have now gone through the journey of tedious design engineering and saw the intricacy and complexity of the design. Now in this entire journey from conceptualization, dream conceptualization, to the design, to the construction erection that we are all going through, I must mention that the principal architect of this project was asked to be Singapore, led by Mr. Min Beng and Mrs. Belinda, supported by our Indian architect, Mr. Sandeep Agarwal, and team practice architect, India. And then finally, to bring it to the reality, our team, we developed our team with L&T, Larsen & Toubro, to do the construction. And for the steel structure, along with Larsen & Toubro, everything was introduced to make this dream into reality. Now I hand over to Krishnendu. Please carry on.
Thank you, sir. Thank you, Ankit. And good afternoon, distinguished panelists, moderator, and all the participants in the webinar. First of all, I'd like to thank MX Business Media for inviting us in this webinar. While the other panelists discussed about the engineering behind Deya structure, I will take you to the finishing stages of atmosphere, including Deya. So before I start, actually, I like to add few important features of the project. The atmosphere was actually conceptualized as an ultra luxurious residential project having 80 villas. This is a B plus G plus 37 storied of high-rise condominium with a steel structure we call Deya, for which we have already discussed a lot. Designed by the Singapore-based architect Arc Studio, this magnificent hanging sculpture is actually a cloud gently floating between the peaks of the two towers. And the span is more than 100 meters with 55,000 square feet of usable space, and will have a silver lining featuring of 15,000 kinetic discs on its surface to keep it glowing. Their structure enthralls you to give you the moment of inspiration. And as discussed by all the consultants, that their designs and dream has come into reality. We are almost there. So I thanks to L&T, Eversendai team, and entire Forum team to make this happen. Now, after the erection of the entire structure, Ankit, next slide, please. Ankit.
It's
hello.
coming.
Yeah.
It's coming.
Thanks. Yes, thanks. Now, after the erection has been done, the next thing we did the fixing of the deck sheets, and then shear stud welding has been done on site, and the concreting, we did the concreting. Here, actually, most of the cases we have done complete M50, M40 grade of concrete we have used, and the composite slab thickness is 150 millimeter, except in central areas where we have generally used 200 millimeter thickness of slab. And the deck sheet we have used here is of tier 60 grade of steel, and shear stud we have used almost 16 millimeter dia and 100 millimeter of length. Now, the another important thing which I like to add on, that is the waterproofing of the entire structure, because it is a very difficult structure. As you see that from the top view, the curved structure, and there is the width wise at the central portion it is 27 meter and side it is 22 meters. So it is not at all a uniform structure. So basically, it's a very difficult for us to execute this waterproofing. So 3 types of waterproofing were used. Non-wet areas we have used PU membrane with the anti-root properties, because the trees are there all over there. And wet areas we have used 2 types of waterproofing. One is we have used crystallization, which we have mixed with the concrete before pouring, and after concreting been done, we have used polyurea membrane. This is basically we have used in jacuzzi, the infinity pool, and the kids pool area. Ankit, next slide. Ankit, yeah. Another point which Ankit has mentioned, that we have used intimation paints, 2 hour fire-rated intimation paint, and the thickness is varying from 10 to 12 microns to 35, 36 microns. Now, another interesting thing that I like to touch upon is their facade. Now, this is a mock-up we have done at the site. This is a visual mock-up we have done. This is the nodal structure along with the perforated panels. These panels are also designed for 50%, 35% and 20% of perforations. And we have used in the structure to see how it looks like and how the fixing can be done on site. So the same thing we have, once VMU has been completed, the same thing we have did in the actual construction on site, which has been done by Mero Asia. Now I will like to start from journey from the entrance level. As you enter from the gate, you will see a guardhouse portal with 4 entrance canopy, which are actually connected with the lobbies. Where each tower we are having a simplex and duplex lobbies, which are connected with the entrance canopies. Now, if you see these entrance canopies, these canopies are made of rectangular hollow sections of 150 by 90 millimeter size, and the sizes of these canopies are almost 9.2 meter by 9.6 meter, having a height of more than 5 meter. And there is a cantilever projection of 3.6 meter of each canopies. And these canopies are covered with aluminum powder coated sections, and the infills are covered with laminated aluminum sheets with PVDF coating and glass. So these are the entrance canopies you are seeing. This is for the simplex and duplex. All the entry levels we are having these canopies. And there is another interesting thing, that is a grand driveway followed by the landscaped areas all along the ground. And on the either side of the driveway, we are having a landscaped areas, which is basically meant for the parking areas. If you see this area, now I'm taking to the next level, which is a E-Tech level. We are having a lot of facilities available in this level, that starting from the badminton court underneath one tower to the toddlers playground, to the children playground, and with the powder toilet and the chess court on the other sides. And a central portion, we have an agora, which is seen visible in these photographs. So this all kind of facilities are available. And now I'm taking to Deya structure. Now Deya, you have seen the skeletons of the Deya structure. Now let us see the finishing of the Deya. It starts at level 32. Now that you see the photographs are there, the reception areas and boardroom. We have boardroom and card room. We have a spiral stair which is connecting to level 2 and level 3. And we have a naturally ventilated lounge with sitting pool table. We have a squash court at this level available, which is already finished. Ankit, please show the next slide. We have a audio video room in this level. And this is a squash court. You see the views of the skylight. Next slide, Ankit. The rondo ceiling and the encased columns. These are all structural columns has been encased with GI framing work and the POPs. This is the photos of squash court, sitting area, and the ramp which is connecting to level 3, which is level 34, which are having all the amenities like swimming pool, jacuzzi, and kids pool. Next slide, Ankit. Ankit, please go to the next slide. Yeah, now the second level, which is level 33 we called, which is having a separate facilities for male and female. We have a spa here. It's having sauna, steam, jacuzzi, everything is available in this level. Now we are going to the level 3 of Deya. Ankit, next slide. Ankit, next slide, please. Yeah, this is level 34, which is open to sky, having all wet areas and the landscaped areas. We are having swimming pool, we are having lawn and party deck, multi-purpose deck, kids pool with slide and jacuzzi, and having a rain dance pavilion. This is, we have already, Ankit has shown you the previous photographs. We have tall trees of more than 18, 20 feet. This is the infinity pool, photographs of jacuzzi. The next one, Ankit. Ankit, next slide, please. Yeah, this is a viewing deck, rain dance, changing room. These all facilities are there at level 34. Next one, Ankit. Yeah, and now we are taking, this is at level 35. This is one side we are having a gym, another side we are having an open party deck. Facilities are there, and we are having a dedicated lifts available at Deya, which will catering 3 levels from 32 to 35. Now there are some fact files for the Deya. Deya as forum, we are the developer of this forum, this atmosphere project. The main architect with Mr. Banerjee is already mentioned, Arc Studio from Singapore, practice design from Calcutta. Structural consultant Wave and MNC both are present in this webinar, and main contractor is L&T, and steel fabrication being done by Eversendai. And steel tonnage, we have used almost 2,340 ton of steel used in this project. And in this project, now the occupancy has already started in this project. The next one, Ankit. Ankit, the next last slide. Yeah, now I would like to discuss with few important aspects of Deya. The first one, that the structure of both the towers of atmosphere needed to have a strong base to hold the sky bridge any kind of weather and during the earthquake. That's already discussed in the earlier presentations. Now, secondly, the UC sections, which Utpal has already discussed. Few of the sections are not readily available in India, so we have to procure from Oras, London. Thirdly, there is a potential risk of movement of sky beach. So every movement was monitored during the lifting work. During lifting, the vertical deflection were monitored. And finally, the transferring of the entire sky beach load into the inadequate isolation bearing placed on two at each tower. So this is basically a construction of Deya makes realize that the flexibility of steel. So we are being a part of this team. So we are a very, very absolutely unforgettable and unique experience we have while executing this project. So with this, there's another last 2 points I wanted to discuss, that this project has already been selected by Nat Geo and has been telecasted in the mega structure called Mega Structure series, which Mr. Banerjee has mentioned. And the last but not the least, we are going to have another webinar session on atmosphere, where our main contractor L&T, Eva Sendai, and forum will be available to discuss on the construction methodology. I wish everybody to participate in that webinar too. With this, I'm concluding my part, and over to Kalam. Thank you.
Hello, I made it back. You have seen that we had a dream 10 years ago. Many of us shared it with the client. Many of us have been with him for so long. We had the dream, I showed it to you earlier. We achieved our dream. And now you can fly around it. Next slide. You can fly around it, you can see it, you can live in it. That was backwards. Let's go forwards. Yeah, let's go. We are all very pleased to have taken part in this project. It has been challenging from the beginning, from the days when we only had piles in the ground, from the days we wondered where we were going to get the steel from, how we were going to put it up, how we're going to keep it all straight, what's going to happen when we put the load on from the Deya, could we lift it and lower it properly. Just for your interest, the end sections of the Deya were secured on the decks up above without touching the bearings. Only once we had the structure in the middle did we very carefully lower each of the 4 bearings to drop the whole Deya onto the building. That was a happy day when the whole thing was safe, secure, and started to look as fabulous as it does now. It has been a great team effort by everybody, client included. We commend the vision of our client to create something so fabulous as this. And finally, thank you very much for being here. We have received questions. We will be answering them. Let us give this back to the moderator to feed us the questions and kits. We relinquish the admin.
Wow, that was truly awesome. If I speak from my own personal experience, in spite of all the glitches, and we lost you a little bit there, Callum, but it was beautifully taken over by Ankit.
Yeah, good man.
No, it's truly a very challenging project, and I'm sure all the people, all the participants would have got that now. I have been sent a few questions, but I'm just going to start a little bit from where you touched in the beginning. And the entire interface of the Deya, or the bridge deck, is obviously with the 2 buildings, and the entire design literally pivots, literally and figuratively pivots on the bearings. So could you just take us through a little bit more in detail of the design of the bearings and why it is probably sourced from US? I know it's a no-brainer that we don't do it in this part of the world, but I'm sure the design of the bearings was so critical that you probably went to the US. So if you could just elaborate a little bit on that part of it.
I think I would like, have you still got Mr. Huang Yu? I can't see him on the list, but Huang Yu, I think the design of the bearings and the requirements for the bearings were developed from your analysis. I think this is probably best comes from you.
Okay, I take this question. Yeah. can we go to that slides for the options? Maybe you want to show that. From a design point of the view, so starting off this this project, we've gone through the various options, you know, over the times actually, from beginning to the final decision to make. So first thing is we think about this the connections from Deya to building could be pin and to supported by the two towers, but this is have the very so-called huge issues, which is the Deya will give the very significant impact to the tower safety, especially when the Deya moves due to the earthquake or winds. So this option one is well reviewed, and option two actually we think of, okay, let's assume the one side is fully released, and it's just one side which is secured by the one tower. But with this one, you will have very so-called adverse impact to your control in terms of the serviceability of the Deya you can achieve, because you are very difficult to control the movements and the acceleration as well as vibrations, also things due to the some accident events. So this option one, option two, we do the study, we do a lot of the analysis also, we choose the modelings. Then we finally say there's something we should do, which is we bring the concept of this, say, flexible in connections. The flexible connections will give you the very good in terms of the safety, which is ultimately design state, and also they give you very good control in terms of safety. Not only this one, it also can give you so-called very good in terms of the maintenance, because we give the requirements in terms of the restorabilities. So this is a story behind the design in terms of the connection between the Deya to the towers. Does that answer the question?
Yeah, a little bit, Huang. So I would like to focus a little bit more on the action of the bearing. It's obviously a spring bearing. And,
okay, understand. The bearing detail is quite special works to be bearing. So we give the requirements and performance the need to the bearing the designer. So the requirements basically we need to have the next slides.
We look at slide 44. We can see some of the technical drawings.
So we need to have the stiffness to control the movements. Yeah, not only this one because of flexibility, we also need to have the higher dampers, because high dampers will give the reduction in terms of the motion to be transferred from the Deya to the towers. So this is very important the parameters we need to have.
Yeah,
in this requirement, which is to give the stiffness in terms of the movements and the requirements for the bearing design.
What you're looking at on the drawing on the left is a series of pistons, each a series of pistons pointing north, south, east, and west. Those pistons are a single rod with a rubber, plastic, polyurethane sleeve down the outside, so that when the piston is pushed in any particular direction, it compresses the rubber sleeves around the piston. This is how the resistance to movement is achieved in all directions. So there, if you look at the bottom, you see the ends of the pistons. Each one is spring-loaded. There is a capping piece that rests on top. There is a polyurethane bearing between the two surfaces, and any movement has to compress these rubber bearings. It's quite a subtle design, really. It does mean, I think one of your questions was about lifespan, and we do have the opportunity in the detail of our design, which was so carefully managed by MNC, to actually change these rubbers, because they will probably not have the same lifespan as the building.
May I add something here, down here? As a principle, you know, it's a spring. It's a principle of mechanism what we have done. Maybe the material is different, material, maybe the lead, rubber, steel, etc. But the principle is there are all direction springs that has been it's a cluster of springs that has been placed there. If you remember in the earlier days, the car upholstery, the seating arrangement, it sits on a vertical springs, it sits on horizontal springs. So, you know, the entire bridge, this entire bearing is based on that principles, is spring in each direction, vertical, horizontal, in either direction of this. I think that's the basic principle, and that we achieved with the various materials, which has a long lifespan than normal spring that we look into. I think that the question has been answered, right?
Yes, I guess so. At least for me, it is. In case anybody, you know, from the participants still feels that it needs to be elaborated a bit more, they can always send it in. My second question here, of course, was, I'm sure it's been done, but I would just like to put it out there any which ways. What about the harmonics? Because there would be harmonic studies which would have had to be done for the buildings as well as for the Deya separately. And then how was it all connected? Because I'm sure that is something which has also gone into the design of the bearings, because the bearings typically are taking care of your wind damping, they're taking care of your earthquake isolation. I mean, they're really performing the core function here. Mr. Huang, if you can just answer that.
Sorry, I didn't get your question. Can you repeat again your question again?
No, I was wanting to understand the study of harmonics, whether that was carried out, I'm sure it was, but what extent of impact did that have? Because it would have been separate for the buildings and separate for the deck, the Deya. And how is it all connected together to give the design criteria for the bearings?
Oh, in fact, actually, they are not separate. We call it separate. It's not separate. They also is connected each other. It's connect each other. The bearing is basically to keep the so-called the much higher in terms of the safety, in terms of the stability, in terms of the maintenance. That to me that's a function of the bearings. Yeah. Of course, the bearing actually is treated as so-called elements, which is quite in terms of design is quite specialized for the bearings. Yeah. But the performance of bearings actually not only design, it's a lot of the things so-called technical to be involved. It's involved the manufacturers, involved the testings, all those things. Yeah, we are not only just simply to use a bearing. We also use top like we are showing there for the testing to perform to prove this so-called the performance of the bearing, which is required before installations. Yeah. So all those have to be through the very careful the selections, studies, analysis, and design. Is that answer your question? Or
also to add to Hwangu, we had a detailed wind study for the human comfort for the building and the bridge, and based on that results, lot of engineering was done on base structures to bring the harmonics.
Exactly. There's some question asking for the wind tunnel. Actually, the wind tunnel is actually we not only did one, we did two. One is overall. Another two. The second one actually is when we identify the performance, so-called requirement of the bearing, we do another one, which is incorporate this so-called performance, so-called parameters of the bearing. Then we do the second one, which is the aero elastic modeling. So we'll give the very, very good in term of anticipating this performance of the Deya together with the tower to the bearing.
Oh, okay.
Is that answer your question?
Yeah. Sure. Thank you. I'll now move on to some of the questions that we've got from our participants. The first question was, of course, on the treatment that was done to the structural steel for durability. You have mentioned intumescent paint for fire resistance and fire retardants. But what about the corrosion and and repair to the intumescent paint in case of damage? So, anyone, Callum or
yeah, we specified a fairly standard specification of a two-part epoxy below the intumescent paint.
Oh, okay.
And that is providing a good 20 years if you look after it. The other aspect of it was, and I saw someone had asked why we didn't cover it all in vermiculite. The answer is we wanted to be able to see the connections. So if we covered it all in vermiculite, we wouldn't have visibility of the bolted connections. We want them to be accessible so they can be checked at intervals in the future. So, yeah.
Can I just add on? Yeah, sorry.
Yes.
So there's two requirements for the steel. One is anti-corrosions, and another one is fire protection to the steel. The anti-corrosion we already have, which is the PIN system, which is specified by the specialist in terms of coatings. And this is a very higher durable so-called coating system to be applied to the steel. Then after that is the intumescent paint to protect the steel from the fire. And the fire actually I was taught this the performance and this so-called requirements is we need to achieve the 4 hours in terms of the fire rate.
Okay.
Yeah. So with this, will be give the very good in terms of the protection to the steel from the fire and from the weathering.
Great. So it's a layered system where you have an anti-corrosion treatment first done to the steel, and then you have a fire retardant layer subsequently.
Exactly.
Great. So coming to another one of those questions which have come in from the participants, someone has asked what subgrade of the steel was used, and in the total time of say 10 years which the project took, what was the steel fabrication time just for the Deya?
Can Anki answer this question?
Krishendu.
Anki, you mute your mic.
Krishendu, if you could answer that question, please.
The timeline?
The construction timeline you are talking about?
Specific to the steel fabrication.
Steel fabrication, we started in the year of 2015 actually, and eventually we completed this within 2018, the main steel structure completion. So it took only 3 years to complete everything, starting from the designing, fabrication, procurement, final lifting of the sky bridge. So it took 3 years almost.
Oh, great. And what was the subgrade of steel used, Krishendu?
I think E350.
Yeah, E350 we have used.
Yes, used.
Okay, great. I thought it was mentioned.
Actually, all the excuse me. Hello. So you are talking of the intumescent paint for the fire protection, as well as we have made a coating treatment as explained by Mr. Wong. And also we had taken care at all the stages with the sandblasting, preparation of surface, and then the coatings, which can give the structure its own lifetime.
Okay, great. Thank you, Mr. Banerjee. Just going to, I think, which is going to be effectively the last question here with regards to bearings. What kind of arresters were used for the bearings? I guess this is a damping system, so there is no real arrestor. It has got its own resistance through the rubber action, right?
That is correct.
Okay, fine. So then I think we'll move on to another question, which is, you know, in a project which is as complex as this, the most relevant thing becomes is the code. I want to know, and I'm sure the participants would want to understand, what codes were used in terms of the design, and then I'm sure Ankit, you would be able to add how did the final analysis, how was that brought into the context of the Indian codes? Because I'm sure the Indian codes didn't cover all aspects of design on this project.
Wangu, you can start on these questions and then I can cover the rest about the codes.
Okay, yeah. The codes actually, initially we are using the India code. Yeah, obviously there will be some areas may not be so-called covered by the India code, or India code not able to cover it. So we are also using the part of this American code, which is ARSC, to check. And also, of course, the rest of it we have to do the prototype, to do the testing, like the wind tunnel. So basically, we are from the design, starting of the design, we are go for this tree approach.
Yeah, and with web structures and design, we integrated the Indian codes and see whether our codes were satisfied or not. At some points, we took higher than allowed from the code for better safety, which was done in American code. And as for earthquake and wind, as we did the actual studies, so we took that. But everything in as far as Indian codes, whatever is specified, and most of the cases it's more safer than Indian codes what we have done till now.
Yeah, the final, of course, strength check in terms of the ultimate mistakes, we are strictly follow the India code. Thank you, right?
Okay, thank you. The other few questions which we are still getting, some of them are coming in from participants with regards to serviceability of the bearings. Someone just wants a little bit more elaborated explanation on how the servicing of the bearings will be done when the Deya is raised by only a few centimeters, or whatever is the limit that you're going to raise it for. And what exactly would that serviceability be? I mean, are you going to be replacing the bearing, or are you going to replace some of the pistons or the rubber? I assume it'll be the rubber parts, because those are the ones which are the most wearable.
If I understand the question correctly, you're talking about the serviceable to the bearing, right? Are you talking about the serviceability design to the Deya, or
No, to the bearing itself.
To the bearing, to the bearing itself. Yeah, you're right. The main item that is the most major service item is replacing the rubber springs inside. The way we get at them, it was a couple of subtleties in the design, and that is, well, you might imagine dropping the bearing onto upstand bolts and you slip onto the top. We did not do this because we couldn't slip it out afterwards. So we made, with the MNC's cooperation, we made it so that everything was bolted down so that we could take out the bolts and slide out the side. Once sliding out the side, we can actually get at the two portions, the bottom and the top plates, and we can invert, we can take out the pistons, we can take out, replace the rubbers, put it all back together again, slide it back into place, and then bolt it down. A lot of thought went into how this is achieved. So jack it up, undo the bolts, slide out sideways. It'll be an operation, but it'll be entirely possible. Lower it down, get at it, change, invert it, change the rubbers on the pistons, lift it up, slide it back in again, drop it down again.
For each of the bearing, for 4 numbers, we already designed, also check with the checking contractor available in India locally. So we can even to the final, replace the piece of the one piece of the bearings if there's something happens to the bearing. So this is already checked and designed in the system. So you can see the 4 corner, you have the like jacking place, and the bottom part, the base also designed into that reaction force already. So this all is considered in the initial design.
Okay, great. Now there is somebody who would like to know, because we saw that most of the elements of the structural steel were already pre-welded. However, it's been mentioned that there were some bolted connections also. Where were the bolted connections designed? I take it where the bridge structure comes near and fixed, which was lifted up and it was fixed to the 2 end connections. Is that it, or was there in any other place also?
There's 2 types of the things. One is the welding to connections. So most of the connections you look at very complex. So, but that one is pre-weld. Then the most of the on-site, not in the sky, but it's below on ground. It is most of it is the bolt connections, which is the splice connections. So then after that, assemblings on ground for the primary structures, then with a stability check, with some additional, probably some additional so-called the brace or strengthening, then we are able to lifting to the sky and in place. Then in place with the entire structures, then we do the connections, which is the bolt connections. So on site, you try to limit any welding connections.
Okay. So basically it's the spliced members where have bolt connections, and you have the ones which are at the junction of the bridge portion and the end portions, right?
Exactly. It's something like that. Yeah. Actually, it's a 2-stage. It's actually a 3-stage. One is a shop, one is on ground, one is in the sky, which is in place.
Okay.
So you have 1, 2, 3 space. Yeah. So it's different so-called connections and different joints doing in the different places.
Okay. So, and the expansion, the thermal expansion has been obviously detailed out in the bolt connections, right?
Yes. Yes.
Okay. Okay. All right. And last is, there are 2 aspects of it. I think we are going to come and try and conclude on it because quite a few questions are very similar. So I hope the participants have got their questions answered. In case they haven't, Carol can always send it to me while we are just discussing 2 aspects. One was on the software used for the analysis. If you could elaborate what softwares were used in which stages and which parts of the project. And subsequently, you could end with BIM. How was BIM integrated into all this? Because we've already seen the 3D models, we've seen animations in that. So I presume BIM did play a big role in this whole project management and implementation and erection.
So I want to say I have to say some name in terms of the software here. Okay. So the initial design, we are using the SAP 2000 and ETAPS. So then the fabrications is the Tekla structures. The modeling is Revit structure modelings. That is more than 10 years ago, yeah. So that's the main 4 software or brands we're using for this project.
So Ankit, would you like to add anything to that? Because I kind of just understood that, well, you've used
we have used SAFE also for the foundation design for this, because foundation was a very critical design for this project. So combining ETABS and SAFE, we did a very heavy foundation designs with this. So yeah, so adding to all the list, I think this was the softwares which we did that time.
Yeah, adding to
But,
Ankit's, let us,
yeah.
sorry, let us
Ankit,
be clear on the role. The entire substructure design was rested upon MN consultants, and because of we are local and we are absolutely knowing very clearly about the soil structure. So the entire load, as Ankit said, it was a pile draft. So the SAFE software continuously added with the ETABS and the SAP 2000, we did a fantastic design of the pile draft, and it came very nicely. And the deflection and the settlement also, we also taken care of very nicely in the software. Thank you. Yeah.
And what about BIM? So what was the integrator software? Because I'm sure there are so many of these softwares which have their own modeling capabilities, but you've got to kind of integrate it together. Exactly. And the management of the project and on-site construction management through a 3D model, which is already there. And you plan for the on-site construction management right in the beginning. That's the only reason why you don't come up with too many issues later on, and you have prepared for all those eventualities as you showed us in the in the process of erection. I'm sure the rest of the construction, no mean task, but it was also it had to be done. So everything to be coordinated. What was the platform that you used to integrate everything, and what was the project management tools that were used?
The design and checks and the fabrication shop drawings platform we are using is Tekla structures. And the modeling for the beams by the structure design is Revit, Autodesk Revit structures. Yeah. So all these two software is currently actually can be worked together. Yeah, because one is very good for the fabrication, another one is very good for the coordinations and to do the conflict detect check.
Okay, and did you use Navisworks anywhere alongside Primavera for PMC and integrate all the models together on a Navisworks platform?
The Navisworks is a part of the Revit structures. It's part of the Revit structure. Autodesk Navisworks is a part of the Revit structures. Yeah. The answer is yes. Yeah.
Yeah. Okay. Thank you. So, are there any further questions, Carol? Because I think we are quite done here now.
No, sir, we are more or less sorted.
All right. Thank you very much, gentlemen. I will now leave you in the capable hands of Avneet and for him to close out. It was a very, very informative and actually an awe-inspiring experience having gone through this project. And it's so easy for us to just look at things and say, hey, great. But you don't really realize the amount of effort, coordination, and specific details that go into making that happen. So the unsung heroes who don't really get seen behind, right down to the welders, the workers who have been there in making this whole dream into a reality. So my congratulations to all of you and all of them. And it's been a privilege to have been here. Thank you very much.
Thank you.
Thank you, Mr. Ruchir.
Thank you for having us. It's been a pleasure.
It was a great presentation, a very exciting project that we had today. And in fact, we have just covered half of it. So we are halfway through the atmosphere where we have discussed the structure, where we have discussed the design. And now we are going to have second half presented on 6th of June. We are going to have a second episode of Atmosphere where we are going to talk about construction challenges and fabrication, how the entire structure got erected, what were the key challenges, what were the areas there which required a lot of planning before execution, that will be taken up by the team of L&T, Lars and Tubro, and Everson Dyer. So we have the link for the second webinar that will be pasted on Q&A section. I request the attendees, the participants to register today. And also there is feedback which we need from you. If you want to know more about the project, if you feel we have not covered some aspects, please drop an email at edit@mxbm.in. So I would like to thank our moderator who have coordinated the entire story, who have weaved it in a very presentable format. All the queries have been solved by him. I think also special thank to the master moderator, Mr. Anand Basil. He is always a great help whenever you need. So thank you, the entire team of Forum project Forum, especially Mr. Krishnendu and Mr. P.K. Banerjee. The web structure team, Huang and Kalam, I think you have shared a great insight. And to set the reference, we had the MN consultant team, Mr. Utpal and Ankit. A great job by all of you. Thank you so much for making this presentation so exciting and interesting. And we look forward to see you guys again on 6th of June when we have the second episode for Atmosphere. Thank you.
Thank you very much. Thank you very much. I want to add
Thanks,
something.
everyone.
Sorry. I want to add something. While the fabrication, of the mid segment was going on, and when it was about to be lifted, we all were there. And when the columns were all, I was referring to Ruchi's statement, the workers and the welders there. I could see their eyes, when it is in the sky. All the welders and this thing, they're staring at that thing that has gone up, and they were just sitting there. And I could see some of them, the tears in their eyes, So the amount of passion that went inside it while the people, all the entire team worked together, and it was amazing. It was amazing. Thank you very much.
Good.
Thank
Good
you.
job.
Great.
Thanks.
Definitely,
Yes,
it was an
see you
exciting
guys.
journey. See you.